So to prepare for our test flight outside, Dave Schaefer, who's done a great job in helping us build this fleet, is going to tell you a little bit about the helicopters and the planes, and then take us outside for a test flight.
Good afternoon. How's everybody doing this afternoon? Doing well? Woo! Enjoying the presentation from Nathan, Alan, and Brian? All right. They talked about doing a number of things using, and they referred to robotic helicopter fleet or aircraft fleet. My job is to take some of their dreams and turn them into reality, to take some of the concepts that they have and make it actually work. My background is over 34 years as a professional pilot, and I hate to admit how many years in excess of that is also been flying model aircraft in various forms, rockets and competition and for fun. So I'm working with them to help develop this fleet of aircraft. And what we have right here is one of the first aircraft that we're using and putting it in an application format, which is this T-Rex 700. Now we're going to go out and fly this thing, and when we do this, I want everybody to kind of line up and stay close to the building. The reason for that is we've flown this particular machine in this configuration that you're seeing today twice. Okay, so we are very much in the flight testing phase of this particular machine. But hopefully when we get this machine developed and configured the way it's supposed to be, it'll be able to provide a variety of missions for these graduate students in terms of doing things that they need to do, whether they're using infrared technology or visible spectrum or doing atmospheric sensing. We'll be able to make these machines do what they need to do to produce that. It is an experimental machine, and I want to bring that to everybody's attention. So as we fly this thing, please don't have your back to it. Please keep your eye on it. Please don't let it go wrong in a bad way. And we'll go out and make some test flights. In addition to the helicopters, there are a lot of other applications that they're using where a fixed-wing aircraft would be so much more appropriate to do that. You can see here that we're starting to build a fixed-wing airplane. The advantage of the fixed-wing airplane over the helicopter for some of what they're doing is the ability to carry increased weight and be able to operate for increased duration. The helicopter, well, has some tremendous advantages to it. I can set the helicopter on the floor here and lift it off and cover it in this room, which would probably upset quite a few people, but it's possible to do that. I can operate the helicopter out of a very limited environment. And it's good for that, but the aircraft, if I have a suitable place to fly it, we don't need too much on that, but we do need a runway to operate out of. We can operate for extended periods of time. We're hoping to go and get the helicopter to operate for about 15 to 20 minutes of shock before we change batteries, which is a very rapid test. We can land rapidly, change the batteries, and go back out. Hopefully the airplane's going to be able to carry more payload and be able to operate for the next 45 minutes. So we'll go out and see what this thing looks like, and like I said, just pay attention to what's going on in all aspects. We'll give you a chance to stretch your legs and have some fun. temperature. The gyros are upset. We'll warm up here for a second. All right, so you can see the camera mount up front, so we can tilt and roll the camera. In addition to that, I can turn some gyros on this system. And now the gyros on, I can stabilize the camera, and be careful. If you notice, as Brian moves the helicopter, the camera's staying relatively stable. So in other words, as the helicopter's pointing at something, we can use the gyro stabilization of the camera mount. And just to illustrate this a little bit better, I'll tell you what, I got the gyros off. Why don't you pick it up and face it toward everybody here real quick. Okay, so if we were filming the audience here, go ahead and pitch and roll. See how the camera is staying relatively stable as he moves the machine around? Again, change in temperature is making it unhappy. There she goes. Let those gyros warm up. One of the things about these gyros is they don't like temperature changes. So as he moves the camera around, the gyros, the mount is staying fairly stable. Let me get it pointed in the right direction here. Yes. Temperature change. So go ahead and just go outside to side. See, it's staying, without me doing anything, it's staying pointed at the audience. In addition to this, we can go ahead and turn this off. This particular machine is what's called a fly-barless helicopter. Most radio-controlled helicopters use a fly bar for stabilization and for control. In this particular machine, when you saw me doing part of my pre-flight setup, you actually saw me lift the machine up and maneuver the machine. Go ahead and turn the other one on. What? Tapping in?
No. What about that fold? I don't want to hold on.
No. So, again, with the machine booted up, as I pick the machine up, and as I maneuver it, here's the swash plate of the helicopter. This is what controls the machine. So you can see if I pitch it, you can see the swash plate moves automatically with no input. Same thing if I roll it side to side. You can perhaps see the movement of the swash plate. So as a result of that, this helicopter doesn't use a fly bar like most other helicopters do. A fly bar is a stabilizer device that goes through it 90 degrees. The plane of rotation has paddles on it. A couple real advantages for the kinds of operations that we're talking about doing. If I was flying a conventional fly-barred helicopter in the wind, I'd be fighting the wind quite a bit, is that we were hitting the gusts in between the buildings. Whereas this one, as the wind hits it, it may slide the helicopter around a little bit, but the stabilization system doesn't let it pitch and roll and react violently to the conditions. The other advantage of it is it's a more efficient system, and by buying a more efficient system, now we can fly longer and use less energy when we're hovering and doing our maneuvers. We're about to see a video that was taken just today, which was really one of the first videos that we produced from the helicopter. And you're going to see the helicopter flying this morning with the camera. Again, this is the second time we've only flown this machine was this morning. And into this video, about 55 seconds into the video, we're going to turn the stabilization on, and you'll see a big difference in the way the camera mount looks and the video looks versus the unstabilized. Brian, if you would please.
Oh, we got sounds over here too.
So if you're sitting in the helicopter, this is really, in this case, Alan was in the helicopter. You'll see him pan and tilt, maneuver the down here a little bit. Just making sure everything's working the way it should. Not a bad picture, but again, there's no doubt that you're seeing the picture from the machine is maneuvering and jumping around in the wind as the previous one. Alan's going to focus on those two containers right there. Just going to pan side to side. Again, not bad video. But you can see the helicopter jumping around there, right there. He's turned the stabilization on. Notice now how smooth. The helicopter may move a little bit, but you see how nice and smooth the image is. It's not jumping around. And this is, again, now it's going to require some tuning. He's going to turn the stabilization off here momentarily. And go back to the normal mode, you can see that we go back to the mode and then shut around again. So by having this, there it is, right there. So you turned it off. So by going from unstabilized now to stabilized now, you can get a much better image, whether it's my image or a different image, and we can have not still. Then we'll come in, take another stabilized image. See everybody waving, say hello. Dr. Larry's going down out here. And at the end of the symposium, I want to get any questions if you have any questions about the machine. Thank you very much.